Hello friends, and I welcome you all in today's class. This is a series in which we are learning geography through MCQs, and we have already done one lecture on this. Today is the second lecture. So let us start our lecture with some more MCQs, starting with the first one. This is a question and three statements are given and you have to tell which of the following is correct. The intertropical convergence zone, that is ITCZ, is a region near the equator where the trade winds of both hemispheres meet. This is the first statement. Then the ITCZ shifts north and south as per the sun, as per the movement of the sun. That is the second statement. And third, ITCZ is responsible for formation of deserts along the Tropic of Cancer. You can just look at this and brainstorm through this so that we'll now focus on answering the question. Taking the first statement, ITCZ is a region where the trade winds of both the hemispheres converge. What is ITCZ exactly? If you look at this image, you can see here, this is a 0 degree, that is equator, and you can see a blue line here, just on top of the equator. This is the ITCZ, but ITCZ is something that is not fixed. It changes as per the movement of the sun. Basically, when the sun is at a place, that place gets heated up. And as you know, as a place is heated, the pressure falls near that place. As soon as this area is heated up, the pressure fall results in the trade winds, that is the easterlies, converging near this region. See, what is happening here exactly is that near this region, the pressure is falling because of high temperature. And due to that, the winds from both the hemispheres will come towards this, like this. They are converging near the ITCZ due to low pressure. It's very obvious. If the pressure is less, then all the things will start to come towards this region. This is known as ITCZ. So the first statement, that ITCZ is a region where the trade winds from both the hemispheres will come, that is true, because you can see this is the northern hemisphere and this is the southern hemisphere. And as soon as the pressure in this region falls, the trade winds will start to come towards this and they will converge near ITCZ. This is the first statement. So our first statement is correct. Now, what was the second statement? It shifts as per the movement of the sun. That is again true. Why? As I already told you, it depends upon sun. If this is the earth, this is a Tropic of Cancer and this is a Tropic of Capricorn, and this is the equator, then as per the movement of the sun, the ITCZ will shift. During the summer season in the northern hemisphere, say 21st of June, the sun will be over the Tropic of Cancer here, and the ITCZ will shift. It is not in the equator, but it will be near the Tropic of Cancer. So ITCZ comes over India, because Tropic of Cancer passes through India, you would know that. So it depends upon the movement of the sun. So that is how the ITCZ will shift as per the movement of the sun. Now, that was our second statement. If you look at the first two statements, the ITCZ convergence, where the winds will converge, the trade winds will converge, and the second one, it shifts as per the movement of the sun. So first statement and second statement are correct. Now we will go to the third statement. ITCZ is responsible for creation of deserts. Again, we'll need to have a idea clear. We do have to have the conceptual clarity here. You don't have to just rote learning. See, this is a cross section. This is the surface of the earth. Okay, now when you look at the surface of the earth here, if this is how the winds are ascending near the ITCZ, okay, because the sun is shining, the earth will heat up and that will result in the rising of the warm air. As soon as the warm air will rise, say this is 0 degree, that is equator, the warm air will rise. Okay, when the warm air will rise, what is going to happen? It will eventually rise and cool down and cause rainfall. Okay, because the warm air will rise and it will result in rainfall. So near ITCZ there is a very high possibility of rain because of the warm air rising. So the statement that ITCZ causes deserts, is it possible? No, but the deserts will be somewhere where once it will reach and then diverge like this in the upper atmosphere, upper troposphere, and eventually at one place it will start to come down. And this place where it will come down near the 30-degree area, there you will find most of the deserts, because it is coming down, it is subsiding, it is subducting near this region. Okay, it's coming down. This place it is rising up. Okay, but here it is coming down, and this is most likely the place where you will find the desert, and not this place. You will not find the desert at the place where you will find ITCZ or the rising air. So that is our third statement. Now you will be easily able to understand and answer this question. Which of the following is correct? Obviously the first statement is correct and the second statement is correct, but the third statement is not correct. This is how you have to answer the questions. This is a very big concept, very diverse concept. This obviously you will have to have a good understanding of climatology. Then obviously this will be easy for you to understand. Maybe you are getting a bit confused. Okay, now coming to the second question. This is again statement based question, that stratosphere is characterized by a rise in the temperature with the altitude, and ozone layer is located in mesosphere. Which of the following statements is correct? Again, let's look at the layers of the atmosphere first. You will be aware of the layers. Initially you will have a troposphere. This is a troposphere, and on top of troposphere you will have stratosphere. This is a stratosphere. So what is the question? In this layer, with the increase in the height, as we go higher in this layer, the temperature will increase. Up until now what we know is that the higher we go, the cooler it is, but that is true in case of troposphere. In stratosphere that is not the case. In stratosphere, the higher we go, the hotter it is. This is temperature inversion. There is temperature inversion in case of stratosphere. So why is it exactly happening? What is the reason for that? Let's try and find out what is the reason exactly for this kind of a thing to happen. Let us take the layer of stratosphere and try and figure out what exactly is happening. Suppose this is a stratosphere. It starts from 18 kilometers up to 50 kilometers. This is the stratosphere. Okay, in stratosphere, why do we find the temperature to increase with height? Because of the presence of ozone. You will find ozone in this layer. Okay, O3. Ozone is O3. This is responsible for higher temperature in this layer. How? How does it happen? Why is there higher temperature? Because of ozone. As you would know, ozone is a combination of 3 O molecules. So there are 3 O molecules in the stratosphere. Now, when there is the sunlight, you will find the sunlight coming, but it will have radiation. Sunlight comes with visible radiation as well as ultraviolet radiation. There will be two types of waves, UV and visible. But in UV, there will still be further UVA, UVB and UVC. Out of UVA, UVB and UVC, UVC is the most dangerous wave. Okay, this is the most dangerous because it has least wavelength. It has more penetrating power, that is UVC, because it is more energetic. When this wave will come, this radiation will come here and strike the oxygen molecules, you will find O2 molecules as well and O3 molecules as well in this layer. When this UVC will come to Earth, to the stratosphere, and it will strike these molecules, it will break down these molecules. So when it will strike this, these molecules will start to get separated. So O3, O2 molecules will get separated as soon as UVC strikes these molecules. That will result in release of heat, because this is an exothermic reaction in which the UVC is causing the breakdown of oxygen and O3 molecules. When the molecules will break, they will release more heat. They will release the heat they have absorbed while they were joining together. Once the heat is released, the temperature will increase in this region. Now I would like to ask you guys, what do you think? When the UVC radiations will come, where will they be more effective? Obviously when we are on the top of this layer. Why? Because the radiations will first strike here. All the molecules that will be present in this region at top of the layer, first of all the UVC will strike these areas, and this will result in the breakdown and release of energy, as compared to something that is here. Less number of radiations will be able to penetrate and come down to this layer. So that is why here the UVC activity will be more, and that will result in more heat release from the breakdown of oxygen and ozone molecules. That is why the temperature in this region as we go higher is more as compared to in the lower areas. So our first statement that as we go higher the temperature will increase, that is true. But the second statement is that ozone is found in mesosphere. Do you think this is mesosphere? What are we talking about? We are talking about stratosphere. So this statement is again wrong. Then you will have to answer which of the following is correct. Obviously statement 1 is correct, but the statement 2 is not correct. That is our question 2. Then coming to third question, greenhouse gases trap heat in the earth's atmosphere. That is first statement. Okay, then these are the examples of greenhouse gases, and greenhouse gases are only produced by human activities. Which of the following is correct? Again, we will have to look at what exactly is greenhouse gas and how it works. As you know, if we talk of the surface of the earth again, say this is the surface of the earth. It is surrounded by the atmosphere, that is a blanket of gases. And let us assume that this is the blanket of gases that we are talking about. Okay, these dots are the blanket of gases that are surrounding the earth. Now we will have different types of gases in this: oxygen, nitrogen, carbon dioxide, water vapors, and many other things. But what is exactly the role of the greenhouse gases? See, when the solar energy comes to earth like this, okay, see, I'll draw it for you so that you don't get confused. This is earth, and you will find different types of gases that are near the earth. Once the sunlight, once the solar energy will come here, it will come like this and reach earth. Okay, what is happening here is that you can see the solar energy comes in the form of, as I already mentioned, in the visible and UV form. So they have short wavelength. They have short wavelength. They are able to penetrate through. They will pass through, and carbon dioxide will not be able to stop them because they have shorter wavelength. They have more penetrating power. Okay, because of the shorter wavelength, they will be able to pass through the atmosphere and strike the earth. Now, once they reach the earth will absorb it, and earth will heat up. Once the earth will heat up, it will release energy in form of longer wavelength, that is infrared, because it's absorbing visible and UV. It's absorbing shorter wavelength, but what it is releasing is infrared, that has longer wavelength. So once it releases the longer wavelength, the longer wavelength will not be able to pass through. Carbon dioxide and water vapors will stop it. Methane will stop it because it has got longer wavelength. That is why it has less penetrating power. Because of less penetrating power, it will get stuck in this region. It will not be able to cross this. Because of that, the Earth's atmosphere will heat up. Earth will heat up. As we already discussed about global warming and this and that, this is how the process exactly happens. See, what actually happening is that once the waves come out here, they will be stopped by the Earth's atmosphere, and that will result in the warming of the Earth. Now you answer the question, how the greenhouse gases trap the heat? Obviously they do. These are the examples, of course they are. But again, they are not only produced by the human activities. There are many other phenomena as well that are responsible for production of this, like the animals and other processes as well, like volcanic eruptions. There are many other activities that are responsible for this. So third statement is not correct, and first and second statement is correct. That's your answer. Coming to the next question, the Hadley cell is a tropical atmospheric circulation pattern featuring rising motion near the equator and sinking motion at about 30 degrees. That is the first statement. Then the Ferrel cell lies between Hadley cell and the polar cell. That's the second statement. And the third cell is primarily responsible for jet stream formation. Now this is an image for you. This will be very easy for you to understand. As I already mentioned you about the IT Caesar, where I told you how the air will rise. The same thing is there. This is the equator, that is the IT Caesar area, where the air will start to rise. Once the air will rise, then it will come and descend down. Okay, and this is near 30 degrees, and there forms a type of a circulation pattern like this. This is known as Hadley cell. Okay, then there is one more cell that takes place from 30 degrees up to 60 degrees. It has got different reasons why it is there. We will learn that in climatology. That is known as Ferrel cell. And finally polar cell as well. So our first statement was that Hartley cell is near the equator. I explained you the formation of Hartley cell. This is true. Then you can see Ferrel cell is in between the polar cell and the Hartley cell. Again, that's true. You can see polar cell and Hartley cell. Ferrel cell is in between. Then the third statement was there that this is responsible for the jet stream, but that is not the case. Jet stream has many other factors that are responsible for formation of jet stream. I hope you understood about this. That is about the statement 1 and statement 2. They are correct, but again Hartley cell is primarily responsible for formation of jet streams. Obviously not. There are some other factors responsible for formation of jet streams. So I hope you were able to understand this question as well. So we have last question. I would like you guys to attempt this question, and in the next lecture this will be the first question that we'll be doing. This is a very easy question. Please answer me in the comments what will be the answer of this question. Okay, then see you next time. Bye bye.